Section 4.3, right triangle trigonometry. Pythagorean triples. Leg squared plus leg squared equals hypotenuse squared. Pythagorean triples. You will see often throughout this chapter. You will see on many questions on the ACT test. Those of you that are seniors and are going to be taking your college placement test at whatever college you are going to next year, a lot of problems involving right triangles, if there's missing sides, will be a Pythagorean triple. Knowing these triples will just save you time on standardized tests or tests where you have a limited amount of time. 3, 4, 5 is the first one. This is leg, leg, hypotenuse. Leg 3, leg 4, hypotenuse 5. These 5 Pythagorean triples are the most common. There are more. These are the ones that you will see. Any multiples of these are also triples. So in other words, if we had 6, 8, 10. And all this means is that in this one that I just wrote, 6 squared plus 8 squared equals 10 squared. 5 squared plus 12 squared equals 13 squared. 8 squared plus 15 squared equals 17 squared. Those all work out to be nice integer values for right triangles and are the ones that you will see most often on right triangle problems on standardized tests. So again, get to know a few of those. It's going to save you some time so you don't have to use Pythagorean theorem every single time to find missing sides of a right triangle. All students take calculus as an acronym to help us remember which trig functions are positive in each quadrant. And this is the key. This is where the trig functions are positive. We go the same direction in which we number. Quadrant 1, all of them are positive. Quadrant 2, the sine function is positive. Quadrant 3, the tangent function is positive. And quadrant 4, the cosine function is positive. So all students take calculus going the same order, starting in quadrant 1 to 2 to 3 to 4. All sine, tangent, cosine. That is going to be key to what you're going to be doing in the next few sections. Find all 6 trig functions when x is 30 degrees and 60 degrees. Again, anytime we're evaluating functions, draw your reference triangle. Rotated 30 degrees, which means that's 60. So we have root 3, 1, and 2. Sine. Opposite over hypotenuse, 1/2. Cosine adjacent over hypotenuse. Tangent. Opposite over adjacent, 1 over root 3, and rationalize. Cosecant, reciprocal of sine. Secant, reciprocal of cosine. Rationalize. Cotangent, reciprocal of tangent, is just root 3. So nothing new from what we haven't already talked about in the previous sections. Draw your reference triangle, use your right triangle trigonometry to find each of the functions. 60 degrees, still in quadrant 1. But now this angle here is 60 degrees, so I have root 3, 1, and 2. And now we're going to do exactly the same thing that we just did. Find all 6 functions. Sine, root 3 over 2, cosine, 1/2, tangent, root 3, cosecant, 2 over root 3 and rationalize. Secant is 2, and cotangent, 1 over root 3 and rationalize. Now, if we look at these, we know that 30 degrees and 60 degrees are complementary angles, meaning that they add up to 90 degrees. Look at what happens here when we switch to a complementary angle. The sine of 30 degrees is the same as the cosine of the complement. Right here. The cosine of 30 degrees is the same as the sine of the complement up here. Cosecant is the same as secant. Secant is the same as cosecant, and so on. This is where the next group of 6 identities come from, which are called the cofunction identities. It has to do with trig functions of complementary angles. Now, there are not 12 different functions here. There are 6. Left-hand column is in terms of degrees. Right-hand column is in terms of radians. That is the only difference. So sine of 90 degrees minus pi is the same as taking the cosine of the complement. Cosine is the same as taking the sine of the complement. Tangent is the same as taking cotangent. Cosecant is the same as taking secant. And secant is the same as taking cosecant. Same thing, obviously, over here, so nothing changes. So on the identity quiz, when these 6 are added, you will be given the left side, you will be providing the right side, and all you need to know is the relationship between the complementary angles and the functions that are associated. So don't remember, 90 degrees is the same as pi over 2, so don't memorize 12 of these. It's 6 of them that you need to know. And then you could be given on the quiz in terms of degrees or radians, but notice the right side, which is the part you're going to fill in, is the same regardless of whether it's given in radians or degrees. Sketch a reference triangle and find the other 5 trigonometric functions, given that theta is an acute angle. Well, if it's an acute angle, what does that tell us? It tells us it has to be in quadrant 1. So we're going to draw these reference triangles we know in quadrant 1. So go ahead and draw a reference triangle in quadrant 1. We're told that the sine of this angle theta, right here, is 5, 6. Well, sine relates the opposite over the hypotenuse. So this side has to be 5. This side has to be 6. And now how can we find the third side? By the Pythagorean Theorem. Leg squared plus leg squared equals hypotenuse squared. 36 minus 25 gives us root 11 for that third side. Now go ahead and find the other functions. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Rationalize. Cosecant, reciprocal of sine. Secant, reciprocal of cosine. And cotangent, reciprocal of tangent. Whoops, I wrote secant wrong here. Should be root 11 over 6. Never mind, I wrote it wrong again. It's the reciprocal of cosine. It should be 6 over root 11, and then we need to rationalize. There we go. Letter B, secant of the angle is 4. And we know it's going to be in quadrant 1 because we were told that it has to be acute. So there's our reference triangle. There's our angle. The secant of that angle is 4. Secant is reciprocal of cosine. So that's, instead of adjacent over hypotenuse, is hypotenuse over adjacent. Use Pythagorean Theorem. Third side here is going to be 16 minus 1. Take the square root is root 15. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Cosecant, reciprocal of sine, is going to be 4 over root 15, and rationalize. Secant, which I already know is 4. You can skip and go to cotangent, is the reciprocal of tangent. 1 over root 15, and rationalize. Last one, number 3. Find each trig function given that the cosecant is 3 and the secant of the same angle is 3 root 2 over 4. So the first thing we need to do is decide how we're going to draw a reference triangle here. Well, both cosecant and secant are positive, which means both sine and cosine need to be positive. The only place in which that happens is quadrant 1. So there's our angle theta. Cosecant, which is the reciprocal of sine, is hypotenuse over opposite. And now we can use Pythagorean theorem to find the third side. We get 3 squared is 9, minus 1 is 8, root 8 is 2 root 2. So there's our triangle. Once we have a triangle, we should be able to evaluate whatever trig function we want to. What is the sine going to be equal to? Opposite over hypotenuse. We could have also gotten that just from knowing our reciprocal identity. Reciprocal of 3 is 1/3. Cosine, adjacent over hypotenuse, 2 root 2 over 3. Tangent, opposite over adjacent, and rationalize. When we rationalize this, we get root 2 over 4. Finally, secant of 90 minus theta, apply your cofunction identity. Secant of 90 minus theta is the same thing as finding the cosecant of theta. Cosecant of theta we were given is 3.